our exam next week, is what I'm guessing.
It seems like they're adding just what we've already learned, but they're adding the math into it now.
Right.
Yeah. So shouldn't be too difficult. Hopefully.
Yeah, exactly. Hopefully.
We have a test next week, is that what you said?
That's what I'm guessing, because there's a lot of things in lesson 7 that are all about review.
Okay.
And there was something in the material. Let me find it.
It's either next week or the following week. I can't remember.
Yeah, it's got to be coming up really soon.
Okay. So you guys got the quiz up?
Yes, I'm ready to
Yep.
go with it. And yeah, Unit 1 exam is tomorrow, or not tomorrow, geez, next week, excuse me, during lesson 8.
Okay.
Is that okay?
Yeah, and it looks like it's due on Wednesday next week, so it's due in 1 week. It's due on the 12th.
Do we still have group quizzes that week?
Yeah, it's showing group quiz is due, yeah, for lesson 8. So it looks like lesson 8 might be covered on the exam as well, because the exam is due after the group quizzes. Group quiz 8 is still due on Tuesday nights as usual. And, yep, Thursday for lesson 9.
That's annoying.
That is. That's kind of a squish in there.
Yeah. Why don't they just? Anyways.
Yeah, no, I hear you. I think the exam should be at the end of the week after all that stuff's done.
Yeah, that's ridiculous. Anyways.
We can always put that in the mid-course feedback.
Yeah. Use the normal. Let's jump in. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358. Okay, round your. Well, that's pretty easy, isn't it?
I got 0.8255.
As soon as I find the normal probability applet, I can. Did they provide a link?
Yeah, they did.
Yeah, they do in what you read.
Right above question 3 in the information.
Yep.
Which section is that in?
It's right on the quiz.
Yeah, it's on the quiz itself. Yeah,
Oh, okay.
right above where it says question 3.
Oh, gotcha. Okay.
Now, in the question, though, it says, find the combined area under the standard normal curve for the right and left. So is that asking for what's on the ends or what's in the middle?
Oh, yeah, it is. It's asking for both. So
my answer was wrong. So that's.
So is it asking just for what's on the left-hand side and the right-hand side and not the middle?
correct.
Okay, so I got a 0.175.
Yep, because you go 3 decimal points.
0.175. Yep.
Okay.
Number 4 says, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, the distribution of the sample means.
I believe it's that first one.
That's what I was thinking, too, the distribution of the individual observations.
Yeah.
All right. Number 5. Which of the following results implies that the spread in X decreases as the sample size increases?
Now that X with the line over it is the standard deviation of. Oh,
I think it's a 68, 95, 99.7, right?
let's see. I believe it's. I thought it was the law of large numbers. That's the sample mean. Sample mean decreases as sample size increases. Sample mean. Is it not the law? It's not the law of large numbers?
I don't know.
Part of the reading is definitely not the central limit theorem, for sure. And it's not a normal distribution because it's not consistent. So it's got to be either B or D. Result implies that the spread is that decreases and sample size increases.
I don't think it's 68, 95, 99.7. That rule.
So I guess the question really is
from-
too, if the sample size increases, would the standard deviation normally go down? Would it decrease? Because if that's the case, then it would be the law of large numbers.
Yeah, I believe it is the law of large numbers.
Fair enough.
Could be wrong. Use the following information to answer the next 4 questions. What is in the quantitative?
Yeah. At one point, we knew how to do this.
Right. Right.
For 160 on the quantitative portion of the GRE. What is the z-score corresponding to Dan's score? Oh, yeah, z-score is pretty simple. 160 minus, this is what you do. You go 160 minus 150.8. 60 minus 150.8. And then 9.2, so 9.2 divided by 8.8. So her z-score is 1.04, 1.045, it looks like. 0.045. You guys get the same thing?
Almost there. Yep, 1.045 is what I got.
I'm happy with that number.
All right. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
So it's within two standard deviations would be 160, so it's 95%.
But that's, let's see. I think we plug in the z-score of 160 into the probability curve of the applet. So 1.045 is the z-score. So I would put 0.148.
So only the left-hand side?
Yeah, above that curve.
Go right-hand side.
Or right-hand side? Excuse me.
Yeah.
Positive, okay.
Or above, yeah, 160.
All right, we on number 8?
Yep.
All right, a random sample of 5 students was selected to take the GRE. Their scores were 160, 175, 163, 149, and 153. What is the z-scores corresponding with the sample mean for these students' scores?
So, we have to find out the sample mean.
160.
So the sample mean is 160 again, isn't it?
That's what I had.
So would it would be 1.045 again.
Is it that
What's
simple?
the z? Yeah, what is the z-score corresponding to the sample mean of these students' scores? The sample mean is just the mean of, means this is they are the sample, and we just find the mean of their scores, and they're the that's the sample mean.
Okay.
So, unless I'm misunderstanding something.
Yeah, I went ahead and found out what the sample mean was between the scores, and it still came out to 160. So the answer should be 0.148 period. So.
No, we mean 1.04.
Oh, I'm sorry. No, I put the wrong. Yeah, I put the wrong one. Sorry.
Yeah, 1.045.
Right. Yep.
All right. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So it would be the same answer as number 7.
0.148.
Yeah.
But
Not
it says
very
round to-
creative.
Well, I think it's just trying to trip us up with wording and stuff like that. But as far as the answer is concerned, though, it also says round to 4 decimal places.
I still have it's 0.1480.
0. Okay,
Yeah.
yeah, this would be the same.
So either we're way off or they're just not very creative.
Right.
This is
But
one he's just sitting there laughing at us.
Right, right. Well, I mean, even some of the questions that we've answered before, even Monday night, or I think it was last Wednesday, where it gave us like 4 different numbers within the problem itself, and it turns out the answer was one of those numbers. It wasn't even that we had to figure something out. So I think a lot of these are there just to trip us up and overthink and analyze.
No problem.
Knowing me, when it gets to the exam, I'll do that.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is skewed left, which means most of them are on the right-hand side. A random sample of n equals 81 students will be drawn. That's above the 45. So, what is the shape of the sampling distribution of the random variable, which represents the sample mean of 81 students? And according to the, what's that theorem? I can't remember what the name of it is. The answer would be approximately normal.
The central limit theorem?
Yeah, that's the one. So according to that, the answer is approximately normal.
So when it's left skewed, when the
Yeah,
central limit theorem comes into play, it's approximately normal. It's not skewed left as well.
Yeah, it doesn't matter. Well, from what I understand of that theorem is if the number is over, or the variable is over 45,
Oh, okay.
then it's going to come back approximately normal. So
It's amazing. It's amazing you remember this stuff. Holy smokes. I remember that now. All right, so question 11.
Yeah. What is the mean of the distribution of the sample means sampling distribution for all possible samples of size 81 that could be drawn from the parent population?
what is the mean of the distribution?
Answer to 1 decimal point.
What is the mean of the distribution of this for all possible samples? I'm not sure I understand the question.
Yeah, I'm not sure I understand that either.
Nice. I feel like we need that one graph that we were working with last time. These last 5 should be fun. None of them are multiple choice.
So what?
I think I might have found it in the reading here.
Are you on 3?
What's that?
Are you on section 3 of the reading?
Yeah.
Yeah.
But we're still skewed, right? It's not a normal. I'm not dealing with the normal
Correct. Yeah, it's
Or maybe it would be normal because it's over 81. I don't get this. Okay, I think I'm understanding it a little bit. What is the mean of this? It's basically asking what would the mean of the sample distribution be? So I think we can find that, obviously.
I think there's a I think the equation is under section 3.
Yeah, I think you're right. So first we have to find the z-score, right? Because we don't have the z-score.
Well, but on the example that they work underneath there, under a normal curve based on a sample mean, it gives an equation there, which is the standard deviation divided by the square root of your sample size.
Oh, okay.
But I don't have any idea if that's right.
Yeah, we might as well try it. I have no idea. Let's see. So it would be standard deviation divided by 9.
Yeah.
And the standard deviation wasn't that 0.7?
Yeah. So that's if the parent population is normal.
Oh, that won't work.
Under a normal curve. But it doesn't say anything if it's skewed.
Hmm. Oh, there we go.
You there, Kelly?
Yeah, I'm trying to get comfortable here, but
So look at this part though.
we're
What
at.
do we do? So since the number is large enough, we still should be able to use that, is what it's saying. So I think it is 0.7 over 0.7 over 9. But that would leave us with 0.1 since they want us to round to the nearest tenth.
Yeah, that's what I'm rounding it to as well.
That doesn't seem right to me. I don't know.
It doesn't, like, especially where the equal is 1 point something.
Yeah.
Let's move on and see if we can figure something else out.
Okay. Number 12 seems like exactly the same question to me.
Yeah.
Oh,
it's just
standard deviation instead of mean.
Right.
Instead of the sample mean.
Yeah.
So there's got to be an equation.
So we're looking for the standard deviation now.
Wasn't the 0.0 or the 0.7 the standard deviation when we divided it by 9?
Yeah.
Now, you're doing that equation in Excel? You're doing that on the calculator?
Just a calculator. What's the standard deviation of the distribution? We might be overthinking number 11. I think it might just be 0.7.
So 0.1 basically.
No, 0.7.
0.
Because isn't there something that says that I think it was the rule is that if it's a large enough number, the mean of the sample means will be the same as the. Oh, I mean, sorry, 3.5. That's what I meant. 3.5. I think the answer is 3.5.
So it's just the same as the.
Yeah. Because the law, whatever the theorem or the law or whatever says that the mean's going to stay the same if the sample is large enough, I believe, above 45. So I think it would be 3.5 there.
And 80 is enough to be a number where.
Anything above 45.
Yeah, above 45, yep.
And then number 12, I think what we were trying to do on the last one is what we should do on number 12, which is the 0.7 over 9, which we get 0.07 8.
Zero point what?
0.078.
Now, will the standard deviation also be the same if the 3.5 stays the same, or will the deviations change?
Nope, standard deviation will go down in the sample means.
Okay.
And then, but the mean will stay the same. I do remember that now.
Okay.
Yeah.
Was that? Do you remember if that was also where you read under the law of large numbers?
Yeah, one of them was the law of large numbers, and the other one was the central
Limit theorem.
theorem.
Yeah.
Yeah.
Yeah. I'm just
Can't
thinking about question 5 earlier.
So for the next one, would we take 3.3 and divide it by 3.5? Or subtract it from 3.5?
Let's see. There's a probability that the mean GPA for 81 will be less than 3.3. So somehow we have to express 3.3 onto this normal probability applet. And we do that by finding the z-score. So yeah, you're right. It would be negative 0.2. So we go negative 0.2, or just 0.2, over 0.7 is the standard deviation.
It is.
Okay. So that would give us 0.286 as the z-score.
But do you count the negative? I guess the z-score is not.
Yeah, it's going to be the same. We're just on the
So
negative
then we can plug that into the,
applet.
yeah.
So what's the number you guys came up with? You said it was -2 or negative 0.2 divided by what?
Yeah, negative 0.2 divided by 0.7. Then you plug that number into the applet. And I got a probability of 0.387.
I like it. So that should be the same.
Are we on 14?
Yeah.
No, greater, we're going to select everything over the left line. So it's going to be slightly more. It's going to be 0.613.
Why do you select? Because wouldn't 3.3 be the middle?
So 3.3 is right at that, is the left red line. So if we're saying over 3.3, we're going to select the middle and everything to the right.
How would the to the left of that left line be 3.3?
What?
I mean, if you go clear to the left line, you are including. I mean,
So right down the middle is 3.5. And then we figured out that how far away that left line should have been for 3.3. Put it right there. And so if they're going to ask for everything above 3.3, we have to select the middle and the right side.
Yeah, I think I'm still trying to figure out the normal probability output as well. But that makes sense. I get that.
0.613.
3. I guess because it's factoring in the standard deviation already. We're taking that out of it.
Yeah, we already figured out the standard deviation for this. For GPA of 3.3.
Okay.
And then, yeah, or we figured out the z-score of it. So. All right, last one. And we'll see how either off or lucky we are.
Right.
Yes, seems the main weight. What are they talking about?
I think I got the answer, but I don't know. I got the z-score, but I don't.
Okay.
It took
Yeah.
177.6, subtracted it from 185, just divided it by the 26.7 standard deviation.
So when they say extreme, they're talking about over 185 pounds?
Or significantly lower, it says. Well, that was my understanding anyway. Either direction.
Oh, so they're just going to ask for the two outside shades or whatever. Or we just have to figure out where to put the z-score.
I think it's I think it's the high and the low, not the middle.
Yeah, that's correct.
I think it's 0.782.
Interference while surfing the web? Your PC may have a potential.
What are you on? You were tempted to only use this one. You were? You got phone? Sure. Okay. I don't know.
Now, Alex, how'd you come up with your answer?
I took 177.6 and subtracted
Right.
185. Divided that
Yeah,
by 26.
I don't see another way to do it, so I guess that would be it. So that's 7.4, and then you divide that into 27. Or divided by 26.
0.7.
Or do you divide 26.7 by 7.4?
It shouldn't matter, should it?
No, it will, but the 7.4. So the equation is supposed to be that the 176.6 and 185 are on top, and then whatever that comes to is divided by the 26.7, which is always the denominator. It's always on the bottom.
Okay.
The standard deviation is always what you're dividing into, so to speak. So whatever your answer is, which is a 7.4, it'll be 7.4 divided by standard deviation.
So we're getting 0.277.
Yeah, that's what I got.
So then I feed in the high side and the low side.
It seems extreme. Well, so the probability, yeah, 78% of people are going to be either. I guess that could be true. I don't know.
Yeah, I mean, if you had children, I mean, they're not going to weigh 177 pounds.
Yeah, they're going to be significantly under that. Yeah.
Yeah, I guess so. Let's go with it.
I don't know. I just don't know what else to do.
I don't either.
So are you guys putting the basically 28%, or are you guys putting 72%?
0.782, I guess would be the answer. All right.
All right, so you got that by doing the right and the left, because those would be the extremes.
Yeah.
I
Right.
see. Okay.
Shall we submit?
I think so.
Does should I submit tonight? I can submit.
Yeah, go ahead, and then I'll do it on Monday.
Okay. Let's see what we got. Looks like we missed. Oh, this was a bad one.
I don't like that. It's not a good sound.
No. We missed the last three. 15, 14, and 13.
And 4. And 8. And 9.
Oh,
And,
jeez. Holy smokes. Let me write these down. So we missed 4, 8, 9, 13, 14, 15.
Yep. The last three are going to be the challenge, though. I was really hoping for a miracle there.
Yeah.
So 4, I'm kind of surprised we answered the way we did. I think it's definitely the second one, not the top one.
Right.
And then 5 we got correct. 6 we got correct. 7 we got correct. 8 we got wrong. This is the score corresponding to the sample mean of these students' scores.
So what was 4? You think 4 was what? The second one?
Yeah. I don't understand how else we're supposed to do 8.
Yeah, I don't either, because I went through and added them all up, and it still averages out to 160.
What is the z-score corresponding to the sample mean of these students' scores? Are we supposed to use the mean of the parent population, maybe? I don't get it.
So do the 50.8 instead of the 160.
Yeah, but then how do we get the z-score from that? That doesn't make sense.
Not at all.
So there's 160, and then what's the mean? What's the mean on that one?
160.
Yeah. If I add them all up and divide it by the 5, it's 160 even.
I mean, what's the mean of the parent population again? 0.2 or something?
Oh, it would be 9.2 because it's 150.8.
Oh,
So
9.2.
yeah, if you subtract it.
Where are you getting?
9.2, and then you're supposed to divide that by the standard deviation.
Right, which is
Maybe we're getting that flip-flop. Are we getting that flip-flopped? What's the standard deviation on that one again?
8.8.
8.8.
Mm-hmm.
So what if we do 8.8 divided by 9.2? So try 0.957. Let's see. Does that make sense? I don't know if that makes sense.
No, I don't think that's right because I just watched a video too before we got on, and the equation is that the value, which is the 160, divided by, or excuse me, subtract the mean to make it the 9.2, and then you divide that by the standard deviation, which is 1.045.
Because the idea is to figure out how many standard deviations away you are from the mean, right? And you're 1.045 standard deviations away from the mean. So yeah, that makes sense. I have no idea what else we could even put for that answer.
1.45. Where are you getting that from? How'd you get that?
1.045 is 9.2 divided by 8.8.
Correct, but that was wrong, right?
Yeah, but I don't know what else we could possibly put there.
I understand.
What is the probability that 5 randomly selected students will have a mean score that is greater than? And because we got that number 8 wrong, we got number 9 wrong, I believe.
What are we doing wrong?
Are we supposed to get the z-scores of all the numbers and then do a mean of the z-scores?
That's exactly what I'm doing right now. I'm almost done.
Okay. That's the only other thing I can think of.
Yeah, that's the only thing I can think of as well.
I would assume it would be the same answer, but
I would as well, but we'll see. It is 1.059.
well, let's try that then.
And the reason why it's slightly different, 1.059, I believe, is because the 149 score is below, so it makes it a negative answer. So when you add all of it up as a sum, it's actually going to subtract from the total.
That's brilliant. Okay. And then that'll change our answer for number 9, or it should, I believe.
Right, what's probably the answer?
Okay, so how did we get that one again?
We put the z-score in, and we did everything to the right because we want to find what's greater.
That's right. So let's put the new z-score in.
Right, so the area came to 0.1448. And it says to put in 4 decimals.
0.1448.
That's what you got, right?
Yep.
Okay.
So on this one, we don't need to add in the middle section, though, right?
Correct. Yeah, it's just to the right because you want to see who's above the mean, and the mean will be in the middle.
Yeah. Yep, just to the right. All right, so we got 4, 8, and 9, I think, hopefully taken care of.
Right.
Now, this is going to be the hard part. Which is weird because I was pretty sure we had this one. We got the z-score for 3.3. And then did everything to the left. Oh. It's primarily at the mean GPA. Maybe it's all different.
What did we have?
You know what? I think on this one we're supposed to do an extra step. I believe. Let's see. So it's negative 0.2. Standard deviation of 0.7. Negative 2.57. 1.
I don't know, because .387 makes sense to me.
Well,
I got .387, but I don't know how we got our last answer.
That was our last answer, was .387. That's what I have. You're talking about for 13, right?
yeah.
Okay. I was looking at 11. Okay.
Oh, number 11 is 3.5.
Yeah. Yeah, I didn't scroll down.
Yeah, because I mean that's the probability. To me, that's the equation. It should be the 3.3 minus the 3.5 divided by the 0.7.
I think we might have to divide it by the 0.0778.
78.
Or yeah, 0.078. Because if you look at probabilities involving a mean, it shows you how to get a z-score for the sample mean.
Yeah, and question 12 specifically says to what is the standard deviation. So if that's the new, so to speak, the new standard deviation to work with,
Yeah,
then that's definitely going to alter the number.
yeah, quite a
Where
bit.
are you guys getting 7.7 from?
That's going to be the standard deviation of the sample means instead of the normal standard deviation. So if you go to the reading under section 3, it shows you that what's it called, the equation to get the z-score. So finding the z-score of the sample mean is a little bit more complicated. So it's the 0.078 instead of the 0.07 or 0.7. So I'm getting a little delirious now.
Yeah, so am I.
I got, well,
Yeah,
Kelly,
but
you can check, but I got negative 2.571.
Oh,
When
you're
you-
taking the answer from 12. Okay,
Yeah.
I see that.
so you did the 3.3 minus 3.5 and divided that by the, which is 0.2, negative 0.2, and then divided that by the 0.078, correct? I got
Yeah.
I got negative 2.5641.
Oh, maybe I did it wrong. Let me try again. Divided by 0.078. Yep, negative 2.564.
Yeah, that's what I got. The issue is though is that if we do below 3.3, which is just the left, it only comes out to an area of 0.0052. That seems kind of low.
Yeah, that seems really low.
That almost barely registers as an answer.
I know.
3 decimal places. So
0.005. I don't know what else to do though.
yeah, I don't either. I was just about to say the same thing. I don't know what else to go with because it seems like it's a standard deviation issue, but it's either the one or the other. It's either going to be the 0.7 or the 0.078. And if the 0.7 was incorrect,
Yeah.
well, I mean, I can always submit mine. We can see where we're at and then go back to the drawing board again.
We'll have Alex submit it since he
I
has.
already submitted mine.
Oh, you did? Okay.
Yeah,
Okay.
I'll definitely submit mine because I'm still on my first attempt.
Oh, okay, perfect. And then number 14. And then on number 14, we just select everything above that,
Right.
which would be crazy high, 0.99 or 0.995.
Yep.
So the answer on 13, you're putting 0.05?
0.005. 5
0.0.
1,000. Yeah.
I'd be shocked if that was right, but I don't know what else to do.
Yeah, I don't either. That's why I'm expecting it to be right.
Yeah, it doesn't make sense.
No, that's
No.
awfully low.
And the other
So-
one's off high.
So we just have 15 to try to work out, right?
Yeah, 15. I have no idea how we even begin to do that one. I feel like they don't give us enough information about what they mean by extreme.
Was there anything in the reading as far as extremes?
Not that I know of. Let's see. I'll search it real quick. Oh yeah, there is. Okay. I guess on number 15 we can do the same thing. I think we found the z-score normally, but maybe we can find it the way we found it on those previous ones. So the random sample is how many?
48.
48. Okay, so we can do. Oh, why isn't it 49? That would be easier. So the square root of 48. Let's do this. So that's going to be 6.928. 6.928. We're going to divide standard deviation over 6.928, which is 26.7. 3.854 as the standard deviation. So now when we do 185 minus 177.6, 7.4 divided by 3 point, what was it, 3.8?
5.4.
3.854. I got 1.92.
So what you did is you took the 48 to the square root.
Now when we do now when we do the extremes, I get 0.055.
I got that same number, but I don't.
Well, my only issue with the equation overall that you did was that the standard deviation, because it's the 26.7, that part should be swapped. So it should be the 6.928 divided by 26.7.
Okay. Well,
And
no,
I remember that from the equation because standard deviation always was on the bottom as a denominator.
not according to this.
Oh,
Not
really?
according to the reading.
Where at what's step and what point?
Under 3. Just the first equation there to find the z-score of the sample mean. It's going to be standard. It's going to be x minus mean over standard deviation over standard deviation divided by the number, square root of the number.
Oh, I see.
Yeah.
So then you came up with 3.854.
Yeah, I got 0.055. Which could be, that's 5.5%.
Well, let's try it and see what happens. Are you going to submit that, Kelly?
Not yet. Hold on. I'm trying to figure out how. All right, and what's the number you guys came up with for area? Came up with what? Go ahead.
0.055.
Let's check this out. No, still got 2 wrong, but 13, 14, 15 are correct.
Really?
9 is incorrect, and 8 is incorrect. Still struggling with those ones. Are you still there, Alex?
Yeah, I'm here.
Nate, you still there? Yeah, I just got a text from him saying that his internet froze probably. So 8 and 9 are incorrect. I really don't know what else to do with those. Let me go back in and open up my quiz again. You still there, Alex?
Yeah, I'm here.
Okay.
So Nate just called. I just sent him another invite.
Gotcha.
Hopefully that doesn't happen to my computer.
Yeah, no kidding. Of all of ours, you're the one heading the or recording the broadcast here.
8 and 9.
Yep. All right. So where are we at with the answers? We have what's 3?
All right. 3 is 0.175.
0.175.
Yes, sir.
Okay. The distribution of sample means.
Yeah.
The law of large numbers.
Yep.
What was 6?
1.045.
Sorry, I'm back.
All right.
No problem.
We missed you.
We're going through withdrawals. What was 7?
0.148.
All right, let me get into this real quick. I need the answers as well.
Okay.
You want to start at the beginning at 3?
Yeah, that'd be great.
Okay, 0.175.
0.175. All right.
Distribution of sample means.
Okay.
Law of large numbers.
Okay.
1.045 is 6.
1.045.
Yep.
Okay.
7 is 0.148.
148. Okay.
8 and 9 we don't know.
Oh yeah, those ones
10.
are weird.
10 is approximately normal.
Okay.
11 is 3.5.
Okay.
12 is 0.078.
All right.
13 is somehow 0.005.
Seriously, I am shocked. That worked.
All right. 14 is somehow miraculously 0.995.
All right.
And 15 is 0.055.
All right. Well, so should we give another stab at 8 and 9? I don't know what else to do. Put some random numbers in there, I guess. I don't know.
I'm surprised we came up with 2 different sets of numbers, to be honest. So.
Seriously. Does it let you leave it blank, or is it, you have to put something in?
You don't have to put anything in, I don't think, but I don't.
Yeah, I'm pretty sure if you hit submit quiz, it'll probably say, hey, you have some unanswered things. Do you want to submit anyway?
Yeah. We'll have to figure out how to do that before the test.
Yeah.
Yeah, I think I don't know what else to do, guys. I think I'm gonna just submit it.
I am as well. I might put in some random numbers, see if by some, I guess that would be.
Yeah, I don't know what else to do with it either. I'm going to try to tinker with it, but I'm also not going to stay too much longer. I got to be up in 6 hours for work.
Yeah, I feel you there.
Yep, same here.
Alrighty, I will stop this broadcast and upload the link.
All right, appreciate it.
Okay, talk to you
No
guys
problem.
later.
You got it, man.
Thank
See ya.
you.
All right.